I just don't want you to see my confused Unga Bunga face. Um,
Got it.
I already got called out once for my lost look. He
oh,
monitors.
All right. Well, good morning, everyone. Today we're going to be going over Docker. And Docker is actually something that's going to be a lot more of a conceptual talk to be able to understand it. Um, and it's super easy to be able to utilize it. And that's the greatest part about Docker, right? So now you may wonder, by the time of this lesson's over, you're going to wonder, well, why didn't we use Docker from the start? Like it would have avoided so many problems, right? And I'm sure we've all realized throughout the process of our curriculum, people who are working on WSL were having trouble being able to run all of their individual dependencies, right? People who are working on Mac OS, maybe they were working in a group and they try to share information with somebody else who was working on a different operating system. And then that just came into conflicts because when you're trying to share information to one another, those dependencies might not be correlating correctly, right? And we kind of touched on this a little bit when we talked about virtual environments and how that can prevent us from having to download a bunch of different things that would actually change and that would actually alter our operating system. And in turn, we would just create a virtual environment where we can put all of our installments. And then all of our installments would just live inside of that virtual environment, and we can share that requirements txt with other developers to be able to set up their own environments. Well, Docker is kind of like the best picture of everything. Docker essentially creates Dockerized containers. Now, what is a container, right? A container is not a virtual machine. A virtual machine comes with a lot of different features into it. Comes with the ability to run Python. You can install npm. You can install X, Y, and Z. By the end of this course, if you run just in your general terminal something like pip list, or if you run something in general, so for example, if I do pip list right now, I can see that I have all of these different dependencies. And if I'm completely honest, I have no idea what half of them are or what I use them for, right? And I'm sure that that's the same case for almost everybody in the class right now. So with that said, that's what's going on in my operating system. Now, for those of you on WSL, when you create a WSL instance or you're inside of your WSL, you're actually inside of a virtual machine. It's not interacting with your own actual operating system. It's just a virtual machine that can have a bunch of different capabilities and limitations. Now, that's good for us as developers because we can create different things. We have the flexibility of going whichever direction that we want. But when it comes to deployment, and we should always be thinking about deployment first, we don't want to necessarily occupy that much space when we go to launch something, right? I would want to occupy the exact same version that I need for Python, and I would want the space that I occupy to be as minimal as possible. I only want enough to be able to run my application, and that's it. I don't want any of the extra stuff that comes with Python. I just want Python 3. I want pip. I want to install my requirements, and that's it. Nothing extra. So that's where Docker comes in. And that's what Docker containers are able to give you. Containers are able to give you not a virtual machine, but it's able to give you a Dockerized container that will hold exactly what it needs to be able to run your project. Nothing more and nothing less. So today we're mainly going to focus on how you go about building a container. So there's 3 steps for doing this. 1, you would have a Docker file. That Docker file would eventually turn into a Docker image, and then that Docker image would turn into a Docker container. We don't need to know exactly what those are at this point. Instead, we can start talking about how we would go about utilizing an actual Docker file. So inside of our curriculum, in day 1, we have an example of a Docker file. And today we're going to mainly be focusing on Postgres, because Postgres is likely going to be the easiest entry point to be able to grasp this information. Not only that, but I remember the struggle there was to get Postgres installed inside of everyone's machine. Right? A lot of people were having problems with ports. Sometimes Postgres was installing, but it was the wrong version, so it just didn't want to run. Well, now I don't have to worry about any of that because I'm going to utilize Docker to host my Postgres instance. So inside of Docker lessons, I'm going to simply create a directory and I'm just going to name it Postgres. So make dir Postgres. So I have this Postgres, and in there, I'm just going to create a Docker file. So Docker file. There's a couple of different naming conventions that we could go into Docker files. We're not going to be covering that today for simplicity's sake, but starting tomorrow, we'll definitely go into how we can change the names of our Docker files to be a little bit more descriptive. Now, in this Docker file, the first thing that we need to know is, well, what image do you want to use? And now we can start talking about what images are. So let me make sure that I have this Chrome going. Perfect. And we're going to go to Docker Hub. So this is where all the images are coming from for Docker. Oh no. I apologize. I thought I would be signed in. There it is, signed in. All right. So now I'm inside of this thing called Docker Hub, and we can see that they have all of these different machines already set up and ready for us. So for example, if I wanted to run something that has to do with Python, well, I could click on the Python official image, and it tells me exactly how to run Python on my machine. Well, in this case, I want to make a Postgres instance. So I'm going to click on Postgres. We can see it's utilizing Postgres, the latest version. I can essentially pull this image from Docker Hub and be able to utilize it. But in this case, I want to create my own. Now it gives me all these different versions, and that's all this is. All of these numbers are just different versions of Postgres that I can utilize through Docker. Well, in my case, or I would recommend for everyone's case, that you always use the latest version. Now, before we just start clicking on latest version, let's talk about Docker images and how you could utilize them. Well, whenever you utilize a Docker image, you always want to make sure that it's an official image. Now, why would you want to make sure it's an official image? One, they're usually most of the time free, right? Especially if they're official images. And two, if they are not official, you are running a risk that they're going to be doing wrong information or interacting with your operating system incorrectly. So you don't necessarily want to interact with anything that isn't official just yet, because it could end up doing more harm than good for you. So I have this file from Docker Hub. Well, let's say I want to use latest. If I click on latest, this is going to show me what the Docker image actually looks like. So this is what it's telling. It's telling it, hey, I want you to grab Debian. And this is actually just another Docker image that this is utilizing. So once we run this, we'll essentially be running kind of like a dependency chain. And then these are commands. So run stands for run this command in the background. And we can see that it's starting to utilize it's starting to create Docker. It's giving it exactly what type of encoding we want to give to Docker. It tells it what information we don't need. So it starts removing information. Here's some more encoding. We can see the environment that it's being set up in. Well, they're giving it the US language. A couple more setup. It creates a directory called Docker entry point and then initialize DB apparently. And it keeps going into different environment variables and how to interact with it. But here we can see that it specifically tells Postgres what version it should be running. Okay, well, this is what I want to run as my own Docker image. But how can I do that? Well, all I would simply do inside of my Docker file, I would specify from, and this is saying, well, where do you want to grab this information from? I'm going to say Postgres. And by saying from Postgres, when I run this image, Docker is going to go to this site, Postgres, and then it's going to come down here and look for which version I want to use. So now I'm going to say, I want you to utilize the latest. All right, so I'm saying, hey, Docker, I want you to go to Docker Hub, go to your Postgres portion, which is where I'm at, and I want you to grab the latest image. Does anyone have any questions on this?
I had my computer restarted. How'd you get here? Did you just create a folder called it Docker lessons, and then you just made the file Docker file?
So I have a Docker lessons folder, yes, and then inside of it, that's where I'm working. Like this, that's what's open up in VS Code. But I created this other folder named Postgres, and inside of it, I have a Docker file.
It has that Docker symbol because it has Docker as a name.
Right. As soon as you name it Docker file, it'll come up with the Docker symbol.
Okay.
We'll go into
You
naming
not-
conventions later on.
Did you run anything on your terminal?
No,
Okay, thank you.
of course.
So Docker is a box in which you're installing different images, one for Postgres. I'm assuming you're going to do one for NPM.
Yes, exactly. So eventually I'll go ahead and create different containers, right? Each container will be based off a different image, and each image would be based off a Docker file. We'll be talking about that as we're going to slowly build up to it. So today we're going to concentrate on Postgres. Tomorrow we'll concentrate on running Django and then linking the Django image to our Postgres, right? Because you could have both of them running without talking to each other, because Docker creates an inner network in the background. So once you start running multiple containers and multiple containers inside of that network, you can connect them all and avoid having to utilize cores or anything like that, because they're all coming from within the same network.
I see. So as I understand, Docker essentially replicates what we did in the starting with InstallFest, where we created an Ubuntu image on our computer. This is a similar, and then we put inside that Ubuntu image Postgres, Django, Python, Node. This is another method, right? That replicates that.
It's a version of that, just without all of the functionality that comes in with Ubuntu. Correct.
Got it. Okay. Thank you.
Of course. All right. So now I have Postgres. I'm utilizing latest. Well, the next thing I want to do is I want to set some environment variables. And we could go down the rabbit hole of reading a bunch of Postgres documentation and stuff like that. Or you could utilize the Docker image that I just showed you. But eventually you'll find out that there's a couple of different environment variables that you can pass to Postgres. One of them being who the user will be inside of this image or this Postgres instance, and what the password will be. So let me create both of those. When I set an environment, it even gives me a hint. It tells me I could do environment and then give it a key value. So let's go into that. Instead of key, what I'm going to specify is going to be Postgres. And then I'm going to say user. Well, who do I want the user to be? In this case, if I go into my terminal and I do the money sign and then send user through it, there we go. ZSH command not found. Ooh, I wonder if it's who am I? There you go. So you could just run who am I. I don't know why this didn't work. This should have worked, but you could run who am I so that it can tell you who the user is, right? Or you could just simply look at your terminal line and it should tell you the user on the left-hand side.
You can do echo.
Oh, I could do echo user. There you go. That's what it was. Echo user. Perfect. Thank you. Appreciate it. Linux commands. All right. So now that I have who I want the user to be, well, I want the user inside of this Docker image to match the user who's running this operating system. I could name it something different, but that's just going to give me an extra tag and an extra thing to remember every single time I run an image. Now, if you're working inside of a bigger company that runs their own containers in a specific way, they might have their own passwords and they may have their own usernames for each individual image. So that's why it's important to be able to read this portion. Who's going to be a user? Well, in this case, it's going to be me. So I'm going to go ahead and change that value for Francisco Avila. And then the very next part is going to be, well, I'm going to specify what my password will be. So I'm going to say Postgres. and I'll specify password. Then you can make something really nice and fancy. In my case, I'm just going to utilize password. All right. So far I'm telling Postgres that that it's going to have a user named Francisco Avila, and that user's password will just be password, and that's it. I'm not running anything just yet. My Postgres living on my local machine will never interact with this. This is a completely new and different instance of Postgres. Well, now I want to be able to eventually interact with this information. I want to be able to get into that SQL terminal, right? Well, can anybody tell me what port Postgres runs? So once Postgres is running in the background and I'm doing things with Postgres, Postgres is essentially running in Daemon mode, right? It's running as a background service because it's not occupying my entire terminal. Can anyone tell me what port it's occupying? No, ran into errors with ports. That's impressive. Say again.
5432.
Yeah, it's actually running on port 5432. All right. So since it's running on port 5432, when I run this container, Postgres will still run on port 5432, but I actually want a way to interact with it. So I need to expose that port from this container so that I can enter it through my own operating system. So I'm going to tell Postgres, or this image, I'm not telling Postgres, I apologize, I'm telling this image that when it turns into a container, I want it to expose the port 5432.
I'm sorry. How would we know about 5432 and what's the significance of it?
Yeah, so you would know about 5432 because it tells you inside of the Postgres documentation which port it typically occupies. Also, if I do something like PSQL, or I apologize, let's say I do drop db does not exist. So I'm gonna try to drop a database that I know does not exist. So when I run this, I'm going to get an error. It didn't give me the correct error. Rough. But I would eventually, at some point you can create an error and it would tell you, hey, is port 5432 denied this call? Is Postgres running in the background correctly? And I believe there's a specific command to check where Postgres is running. Let's see.
I just wonder if that's the system reserved port for Postgres.
Correct. That port is going to be reserved for Postgres every single time.
Okay, got it.
Yeah, I'll definitely find this terminal command later on, but you're right. This is probably not the right time for me to start doing that research.
It just seemed like something we should have known, and I felt stupid for not knowing that.
Yes, it should have been covered during the PostgreSQL module. I don't believe I taught that, but if that did not get taught, that is definitely something that we'll have to address later on. Oh, you're saying it's netstat 8? Let's check it out.
So if you got the tools installed,
Oh, hello.
and depending on how you're running it, yeah, it looks pretty crazy on a VM or something. That should show you all your ports and everything that you've got exposed currently.
Okay.
That should be everything on your machine, but yeah, that's a lot, probably.
Yeah.
Because is that a virtual machine or something?
No, but it's all right. We'll go ahead and continue with what we have so far.
Yeah.
We're trying to think like that.
That was more than enough. I appreciate the answer.
Yeah.
Thank you.
All right. So now the next part's going to be, well, what do I want to name this database? All right. And again, this is just going to be an environmental variable. And I can specify the database name. And I could do that by just saying Postgres _DB. And I'm just going to name it container to do DB. That way I know it's different from the database that I actually have. Because right now, I believe I do have a to do DB. right? So I have a to-do DB living inside of my local machine. So I'm going to name this one container to-do DB so that we can see it, that it's running on Docker rather than running on my actual machine. Okay, and then finally comes this encoding argument. You could definitely leave it as the default value so you don't have to specify this. But in our case, I'll show it to you. I don't have this memorized off the top of my head, and it is shared with you all on the notes. But all this is doing is saying, hey, when this Postgres instance gets initialized, so it's initializing a database, all right? I want these arguments to be, hey, this is how I want you to encode my information. And I think there's a couple of other, these other three are different arguments. I can't really remember what they are off the top of my head. Let me make sure here. I believe I have an explanation for them. Yeah, so it looks like encoding UTF is saying, hey, this is how I want you to encode it. /C is saying that it sets the collation order for the database. That's going to be an interesting term that I'll have to look into. I'm not exactly sure what collation stands for. This portion here of LC C type C is just saying which classification of a database it's going to be. And then this data checksums is just basically saying, hey, the data will be checked before it gets inputted into the database. All right. Does anyone have any questions over the progress that we've made thus far?
So let me just get this straight. You're essentially just setting up the environment here, aren't you? You're like maximally typing in what kind of environment you're trying to create.
Exactly. So I'm trying to say, hey, I want a Docker container to be running, and this Docker container should just have a Postgres environment, be able to be accessible for me.
Does the order matter of how you type everything in there?
You could have, as long as this one is first, that's all that really matters. After that, I believe these could come in any order. Any environmental variables could come in any order, right? Because if I think about it logically, technically, this would have to come first, then this second, it would create a database, and then afterwards my user and password would then be created. But I believe the environmental variables don't matter because it's going to create this image first. And then after it creates the image, then it starts reading your environmental variables and applying them to Postgres. Does that answer your question, Brian? Okay, perfect.
You got the Postgres initdb args from the documentation, correct?
Postgres initdb, yes, correct. All of these environment variables are coming from the Postgres documentation. All right. So now the very last thing I need to do is actually initialize Postgres. Well, I know that in my terminal, I have to do this whole thing like brew services start Postgres or brew services restart, and I have to stop it and run it again, et cetera, et cetera. Well, in this case, since this is interacting strictly with Postgres, all I have to do is run Postgres. All right. And this is going to say, hey, initialize Postgres. Now, we've seen run before, and we've seen command now. Can anybody take a guess at what the difference between run and command is?
I guess the command, it just gives the shell command, and the run actually the Docker's own stuff. You can write it without the quotation marks.
Yeah, that's good. That's correct, right? So both run and command are going to be giving terminal inputs. They're both going to be interacting with the terminal of this container per se, and they're going to be running commands to it, right? But the difference is that run are commands that should run while the container is being built, and command is the final command that should be executed once the container is done being built, right? So if I think about Python, I could essentially have a run command that will make migrations and migrate, right? Thinking about Python and Django. And then my command could be run server, because at the end of it, I wanted to make sure that it's running my server. Okay, so far, I've created this entire Postgres Docker file, but Docker doesn't know about this. It doesn't know it exists. So now we can go into actually interacting with this Docker file. Well, let's talk about Docker real quick. I can go into my terminal and type in Docker, and it's going to give me a bunch of different commands. And actually, this might be more beneficial if I just bring it up here. All right, it kind of gives me a pretty small description of what each one of them do, but these are all the different commands that I can run through Docker. I can check what images I have by running Docker images. All right, we can see that I was practicing before, so that's why I have these other containers already built in here, right? Sorry, not containers, these other images already built in here. And I can run Docker PS to see all of my containers that are alive. All right, so currently I don't have any containers, so it's not going to tell me anything. Is this big enough or do I need to zoom in? Okay, cool.
It's good.
Perfect. All right. So now let's go ahead and build this Docker file, right? Because I want to turn it into a Docker image. So I'm going to have to build it. Well, I'm going to make sure that I'm inside of the correct directory. So I'm going to change directory into Postgres. I'm going to run ls to make sure I can see my Docker file. Okay, so it's looking at my Docker file. And then I'm going to run the command docker build -t and -t. So Docker build is saying, hey, I want you to grab this file and I want you to build an image from this file. Okay, so Docker knows now, all right, well, I got to build an image from a file, from a Docker file. Well, where is that Docker file? So since I didn't specify a path for my Docker file as to where it is that it's going to find it, it's just going to look inside of the Postgres directory or whatever directory I'm currently on, right? So that's why I had to change directory into Postgres. So I'm inside of Postgres. Here's the Docker file, Docker build. Docker's going to say, all right, well, somewhere inside of this directory, Postgres, there should be a Docker file. So it finds my Docker file and it starts reading it to be able to build it. Okay. So now the next part's going to be, well, where exactly, what is it that we want to name it? So this -t stands for tag, right? So we can see here we have tag, and actually that's not it. It's going to, this tag is going to show up as the repository, right? So now I'm going to say docker build -t, and let's say I'm going to call this one uniform Postgres. Okay, and then I'm going to tell it it's inside of this directory by putting this period towards the end, right? Hey, look inside of this directory, find the Docker file, build it, and I want you to name it uniform Postgres. Well, now when I click enter, we're going to see, all right, well, this Docker, it looks like it already finished. So that happened super fast. It took exactly 0.1 seconds. It went into the Docker file, find the definition. It grabbed the correct Docker file, which was 316 bytes. And we can see that it's starting to initialize Postgres here. It grabs the image, it exports it. Okay, well, now that it's done, I should be able to say Docker images. And when I do Docker images, I should see uniform Postgres is now populated. If it takes that long for you guys, it's likely just because this is the first time you ran Docker.
I had a question, Francisco. Oh no, I forgot it.
Okay.
God dang.
All right. Any other questions?
Sorry. You said you didn't need the entry point command because there's only one Docker file in this folder.
Right. There's only one Docker file in this folder. Go ahead, Roger.
They're reminding me. Yeah, so what happens if you have multiple files in that folder? Like, how would you specify which file?
Yeah, that's a really good question. We're going to be going into naming conventions and how to specify each individual file tomorrow once we start working with separate Docker files. We're not quite there yet.
Awesome, thank you.
Of course. All right. So now I was able to grab my Docker file and create a Docker image. So now I build a Docker image. When I actually want to interact with that Docker image, or I want to create a container, well, that's where the command of run comes in. We're going to run this a couple of different times so that we can see what each individual instance is doing. So again, if I run Docker PS, it's going to show me which containers are alive. Currently, it's just showing me the headers. So that tells me that there is no containers currently living. I just zoomed in to make sure that we can all visualize this a little better. All right. Well, now let's go ahead and interact with this image. And I'm going to do it a couple of different times because I want to make sure that we can see what each individual flag is doing and how it works. So first, I'm going to do the most basic command. I'm going to tell Docker that I want it to run a specific image. So I'm going to say Docker run uniform dash Postgres because that's the name that I gave it. Okay, and that's everything I'm going to use. So I'm going to say Docker run uniform dash Postgres. Okay, so we can see that the server was able to run correctly. And let's look at the different commands that it executed. Okay, so here's where I started Docker. Told Docker to run. So the file belonging to this database system will be owned by Postgres. Okay, so that's the first initial user. All right. Now the database cluster, so this is telling the database, hey, how's it going to be working? And that's where we pass that encoding stuff. So this is all line 9. All right, we can see that it has the collate of C, the type of C, and here's the UTF portion. All right, and then it looks into the default language. It's going to be set to English. The database checksums are going to be enabled. That's just saying, hey, I want you to check data before it gets entered inside of my database. This is fixing permissions. So it's saying, hey, who else do we want to add permissions to? It runs all of that information, which, to be plainly honest, I'm not sure what's going on in this portion. But if we come down, we can see that it's saying the installment was successful, and now you can start running the database server. So then it shows Postgres running. And what else? Oh, here we go. So now it creates a database, and that's this portion where I told it, hey, this is where I want the database to be named. And we should see one for create role as well. Okay, I'm surprised we didn't see one for create role, but we could at least see the create database. Okay, so Postgres is now officially running, and here it even tells me, hey, this is where I'm running. I'm running in 0000, and I am in port 5432. Right? Okay, great. Well, this is fantastic, and I'm officially running a Docker image. If I create another terminal and I run Docker PS, I'm going to be able to see that a container was made. It gives me a container ID. It tells me the image that this container was built from. Tells me an entry point, where it came from, when was it created, what is its status. So right now it's saying that it's been running for 2 minutes now. The ports that are exposed, which in this case is 5432. And then this name. I didn't give my Docker container a name. It ended up giving it a name for me. Yes, I know. Docker just wanted to do its own thing. All right. So now I have this information. But I don't necessarily want this occupying an entire terminal every single time I run a Docker, every single time I run a Docker image to build a container. So I'm just simply going to Control C to stop this. So now we can see that it shut down the database. If I run Docker PS, that container is no longer listed. But if I run Docker PS-A, we can see that container still exists. Now, -A is just showing me a list of all containers, including containers that I've stopped before. All right. Docker PS only shows me the containers that I currently have running. Okay, any questions over what we just did? I know we haven't got into the fancy part where we're actually able to interact with it just yet. First, I want to get us familiarized with the different Docker commands.
Can we run the Docker as a daemon, like in the background?
Exactly. Yeah, so that's the next thing that we're going to go into, right? Well, what if I wanted to run it in daemon mode? So let's do that. Let's say Docker run -d. And that -d stands for daemon mode, meaning that it's going to be running as a background service and it will not be occupying my entire terminal. And now I just simply have to specify, well, what image is it that you want to use? So I can say uniform -Postgres. Okay, and it gave me this little encoding thing. Well, that's just giving me my container ID. So now if I run Docker PS, here we see the container ID, the image it was built from, the entry point, and when was it created, what's its status, what ports, and then we can see that it generated a new name since this is a new container.
Did
Okay.
you have to stop it before you ran it again? Or did it just create a new container off of that same image?
So you could just create a new container off of that same image. They shouldn't conflict with each other. But you generally do want to stop it. So remember how I was running this other terminal? When I did Control C, that killed the terminal, which means it killed the container.
Okay. Yeah, no, I missed that part when you killed that other one.
Yeah.
Okay.
All right. So now I can close this one since I won't need two terminals anymore. And I have this running correctly. Well, now it's running on daemon mode. But how do I stop it? All right. Well, I can just grab the ID. And I believe the correct command is Docker stop. Oh, hello. Let me make sure that's being copied correctly. I'm not sure why that didn't work. Okay, and it just gives you back that little code all over again. Notice how I didn't have to grab the entire string of the container ID, or I just grabbed like the first 5 or 6 characters. As long as it's unique, it's not going to matter how many characters you include. So for example, if none of them started with the letter delta for all the different containers that I had, I could literally just put Docker stop delta, and then it will stop the correct container for me. Would restarting the computer stop the containers? Yes. All right, so now I can say Docker PS, and now we can see that there's no actual running containers. But as I'm doing this, we can see that in Docker PS-A, I'm building more and more of these images. Well, I mean, more and more of these containers, right? I don't necessarily want them to stay all the time. I want them to be removed as soon as I'm done using them. So now I'm going to go into the next flag. Well, I'm going to say Docker run. I want it to run in daemon mode, but I also want it to be removed. So I want to do --rm. And all of this is saying is, hey, I want you to run the following Docker file. I haven't named the Docker file yet. I want you to run it as a background service in daemon mode. And then when I'm done with it, I just want you to remove it. Okay. Well, now I can say uniform Postgres. It builds it. I can run Docker PS. I can see it created a new one. But now, when I go to stop this specific image, or sorry, this specific container, I need to watch my verbiage. We are going to see that when I run Docker PS-A, there's not a new entry for it. There's still only 2 uniform Postgres. And that third one that we just ran was automatically removed from the --rm flag. It's just a convenience flag. I don't want to have to come in here and manually remove each one of these every single time. So instead I just do the --rm. Any questions over the couple of flags that we've gone over so far? We've gone over how to run a container in a background as a background service, and we've gone over how to remove a container as soon as a container is stopped.
What does PS stand for?
That is a good question. I'm not exactly sure. I'll have to figure that one out.
It's fine. Maybe I missed something. I think. But what is daemon mode?
Yeah. I believe you were here for the deployment lecture, and during the
I
deployment,
believe like the last hour.
oh, got it. Okay. So daemon mode is just basically saying that something's running in the background instead of occupying your entire terminal. Right? So when we run Python manage VY run server, that's occupying an entire terminal. Right? I no longer have control of that terminal. Django owns it, and it's just telling me how to receive requests back and forth. Well, daemon mode would be where that runs in the background, and I still have control of my terminal. So I can run different commands. Does that make sense, Roger?
Yes, thank you.
Of course.
Francisco, I got a quick question. So now I have 2 containers with an image uniform Postgres. Do every time I start a new, I guess, every time I do a Docker run, it's going to create a new container?
Correct.
Can I access the container that I stopped before, or is that inaccessible anymore?
I believe you can. You should be able to copy this, and just like there's a stop command, there should be a Docker start. You could specify the list. So now you could see that I ran it and it gave me back that code, right? Well, now if I run Docker PS, it's running that old container.
I'm just wondering, like, why is it creating a new container every time I run it? Let's say I run it 10 times. Is it going to create it 10 times?
So Docker run is specifically for creating a new container, right?
Oh, okay.
Docker
That
start
command.
is for grabbing an already created container and starting it or stopping it.
I got it. Thank you.
Okay.
Yeah.
Perfect. Okay, so let me go ahead and stop this Docker image. This Docker container. Docker stop. And if I run Docker PS, everything still runs. All right. So now there's just a couple more flags that I want to cover. The simplest one is going to be the naming one. As you all may have noticed, we're getting this naming convention. And it's a little weird every now and then, right? So now let's go ahead and give it my own name. So I'm just going to run the same command. I'm going to say Docker run. I want this to run in daemon mode. I want it to be removed as soon as I'm done running it. And the image that I want you to utilize is going to be uniform Postgres. Well, now I need to give it a name. So I'm just going to say -- name. And let's say I name it Postgres. Okay, so we can see that ran. It gives me back the little container ID that I can utilize to interact with it. Well, now if I run Docker PS, oh, that one failed. Interesting.
I think it's because you didn't do a underscore with uniform Postgres.
Does it have an underscore? I don't believe
No,
so.
it's a dash. It's a dash.
Yeah.
Want to make sure that I still have that image. I do have the image. Interesting.
You have one from. Oh, that's the image you're looking at?
Yes.
Okay.
Let me see. So Docker PS doesn't have it. So let me make sure. Docker run in Daemon mode. I want it to.
I guess
move
the naming convention was kind of like different. Can
Was
you
it
put, yeah, can you put like adjective on it, like new, I mean, what do you call it? Something Postgres instead of just giving Postgres.
Oh, I see what you're saying.
It's colliding with something else because there's something Postgres in your system.
So let's say Docker run -d -rm uniform Postgres, and let's give it a name, and let's just call it my SQL or my Postgres. Okay, so now if I run Docker PS, it's still not running. Interesting. Let me make sure that this is even running without the name portion. Oh, I didn't give it Docker run. I apologize. Let's see, Docker run. Docker PS. Okay, so this is running if I don't pass it a naming convention. Interesting. Oh,
I don't think it doesn't like where you're putting name.
yeah, I'm passing in the command wrong. That
Yeah,
would
you
do
want to
it.
give it name before.
So Docker stop, and let me pass in this ID. That went from being simple to being not simple. Okay, so again, I'm gonna go ahead and run this Docker container one more time. So I'm gonna say Docker run. I want it as a background service, and I want it to be removed. Well, right after that, I'm gonna specify the name for it. And I believe the first thing I need to do is specify the name, and then after that, which Docker image is it that I want it to run. So let's call it my Postgres. And then the image that I will run it to run is going to be uniform dash Postgres. There you go. All right. So Docker run is going to identify the image and build a container. -d will run this container as a background service. --rm will remove that container as soon as I'm done using it. Or I stop the container, right? And --name is just going to give it an actual name rather than letting Postgres create one for me. Okay, perfect. So that's pretty cool. I'm able to give it my own name so I don't get something ridiculous. And now comes the very final flag. And I know that these were a lot of flags and these commands can get a little stretched out as we continue on going. So now let's go ahead and stop this image. So let's say Docker stop, and I can reference to it by the name that I gave it, my Postgres. So now if I run Docker PS, it's gone. And now what I'm going to do is I'm going to link this Postgres this Postgres container to my actual machine to allow me to enter the Postgres container that I made. All right, so let's go ahead and start doing that. I'm going to go ahead and say Docker run. I'm going to run this container. I want it to be running as a background service. So what would be the next command here?
B.
All right, so we would be
D.
perfect. And now I want to specify what port is it that I want it to link to. So I'm going to say -p. And -p is saying, hey, I'm making a connection with ports from my local machine to the containers ports. So now in my machine, I know that in 5432, that's where my PostgreSQL is living. So I don't want to link it to my own 5432, right? Instead, I'm going to go ahead and choose a different port. In my case, I'm just going to go with 5433. So that's where it's going to be running in my machine.
Is that an actual port?
Say again?
Are these actual ports?
Yes, this is an actual port inside of my machine. Was that your
How do you
question?
check those? Like,
Say
how do you
again?
check all?
How do I check all of the ports? Well, there's quite a bit of ports that are available in your machine. We can definitely go into the rabbit hole of finding out how many ports are inside each individual machine. But essentially, you should be able to come up with a 4-digit number, and that should be free and opened. If it's not opened, it's going to give you an error saying like, hey, this port's already occupied. There you go. Done hooking it up. There's 65,000 ports. So, all right. So now we have Docker run. It's running as a background service. And I'm telling it, hey, when I run this container, I want you to link something to 5433. Well, what port from the container is it that I want to link to? Right. Well, when we created this Docker file, I exposed 5432. So that means that the only port that I can connect to here is going to be 5432 because that's the only port that's exposed. All right. And then everything else still continues the same. --rm, --name. Let's continue calling it my Postgres since that's been deleted. And that's going to utilize the uniform -Postgres image. So that's going to create it. And now when I say Docker PS, okay, so it looks a little bit different than what we've seen so far. So now with in Docker PS, I can say, hey, here's the container ID. This is the image you're utilizing. Here's the entry point for Docker to be able to work with this with a specific image, or sorry, with a specific container. It was created 5 seconds ago. It's been up for 5 seconds. And then we can see that ports changed a little bit. Well, in ports, I'm saying inside of my own machine at 5433, you can interact with this containers port 5432. And then I have my name of my Postgres. Now, what does that mean, right? I just linked these two. What exactly does that do for me? Well, now I can actually enter my Postgres container. So let's go ahead and enter Postgres. I'm still going to utilize PSQL. -H stands for host. So who's hosting this, right? Where is it being hosted?
That'd be your 0.0.0.0.0.
Right. So 0.0.0, which stands for local host, right? So I could either specify the specific host or I can just write localhost here. All right. So PSQL.
I'm sorry. I thought 127.0.0.1 was localhost. Is that different? Or I was wrong.
So that goes a little bit more in depth into how localhost actually works. And it's kind of opening up this Pandora's box. But basically, there's a couple of different access points that we can enter localhost from. Right. And they're just running on different domains per se, so that you can run multiple applications. Does that make sense?
It does. Thank you.
All right. So now I've specified where the host is. And now the next thing I need to specify is what port I want to enter from. So what port can I utilize to enter?
5433.
Yeah, 5433, because that's where I told it that I would build that connection. All right. So now I have, am I up on time? No, I'm not up on time. Okay, I still have time. So now I'm telling SQL, hey, I want you to check my local host at port 5433. And I want you to enter the database that I created. In this case, the database that I created was container to do. So I'm going to copy that. I have container to do. And when I run this, it's going to likely ask me for my password. Well, let's run it. There you go. So now it's saying, hey, the user is Francisco Avila, and it's matching me as the user. Well, now it wants to know what the password is. And I specified the password. Oh, it's probably blind typing to be password. And now I'm inside of a container, right? We can see that I'm in, where can we see it? Oh, it's actually not showing me. But now I'm actually inside of a container, and I'm inside of the database that I just created named container to do. And everything in here it still works the same. I could run /d to see if there's any type of relationships, /l to see the other data tables. So we can see Francisco Avila is the main owner of all the tables in here. All right, there's still Postgres. I can still create other databases, I believe. So let's go ahead and create database. My V. It can still do simple commands like that. If I run /l, we can see my DB populate. Right, but all of this information isn't living inside of my machine. It's living inside of the Docker container itself, right? And it's only running specifically what I told it to run. I could build off of that, add and take away once it's actually running, but the container is as slim as it can possibly be, and it only gives me the services that I told it to give me explicitly.
So since you put in the remove at the end, any changes that you make to this, the container is going to get blown away. So you'd have to remake those changes later on. So you only want to remove it if it's something you're testing, or what's the purpose of removing it?
Exactly. So you would essentially want to remove it whenever you're inside of the testing phase, right? Or if you know that you're going to have to rebuild your database afterwards, you could remove it. Otherwise, you would just want to stop it. You could still hold on to the container, and the container would hold on to its own information through volumes. We won't go into volumes until a little bit later once we actually start making our full stack application through Docker. But it'll hold that information through volumes. So every time we run the container again, it's able to have the data that we already had inside of it previously. Does that answer?
Cool. Yeah, absolutely. Thanks.
Perfect. Ivan?
Oh no, it's just my computer thinks that localhost is 127.0.0.1. So instead of localhost, I had to put 0.0.0.0, and it worked.
Oh, perfect.
So I guess you can just put, moral of the story, I guess you can put zeros or just an IP there instead of localhost.
Yeah, you could just specify this apparently. Awesome. Any other questions?
If you make changes to your Docker file, do you have to like redo all this all over again?
That's a really good question. And yes, if you make any changes to your Docker file, you would have to run the image one more time. And then the image, you would have to run the file again to be able to create an image. And then you would have to run that image to be able to create a new container with those updates. Right? So we can see how this turns into a hassle once we're actually working with Django and like React, and we're making some updates. Well, now every time we make an update, we would have to go inside of Docker, kill the current container that we're on, and remake the image from the Docker file, and then remake the container from that image. Does that answer your question, Ryan? Okay. Don?
We got a quick question. When we start making multiple containers, was there a spot inside the Docker file where we could assign the IP instead of using 0.0.0.0? Because if we make a second one and it assigns it to all zeros as well, when we have some type of conflict on which one we're connecting to?
That's a really good question. And so although you would think that, yeah, we would have some type of conflict. Remember, Docker containers build their own network in the background. So they're never utilizing the same exact domain or the same IP whenever they're talking to each other. So I can build multiple containers as long as they're all running on their own separate ports. I won't have a conflict when I go to connect to it.
Okay, that makes that a lot easier to maintain then.
Exactly. Yeah, and that's one of the biggest benefits of Docker. All right. Any other questions? This is all the material that we have for today because we want to make sure that we just cover the very basics and then we'll build up as we continue going on. So are there any other questions over anything we covered today? Okay, perfect. I'm going to go ahead and stop the recording.